All right, here we go with the beginning of Unit 3. We're talking complex numbers today. So if you thought math was difficult before, just wait. Now we're getting into complex numbers. I'm just kidding. This is actually pretty basic so far, at least to start here. So first of all, what is a complex number? It's just a number in the form of, oh my goodness, we're all over the place. A plus B, I. The I stands for imaginary, where A and B are real numbers, and BI is the imaginary part. Okay, so just to take a look over here, we have the real numbers would be A plus this B value would be zeros, like -1. 5 over 2, 3, pi, square root of 2. Those are all real numbers. Imaginary numbers look like this. 2 plus 3i. 5 minus 5i. The I stands for imaginary. And then these would be just pure imaginary numbers. There's no real part out front here. So -4i, 6i, and so on. So the imaginary unit is what we use to find square roots. I don't know what happened to the rest of that, of an imaginary number. For example, we all know what the square root of 16 is. Hopefully it's 4. But if you take the square root of -16, we always just said there's no real solution. The key word there is real. We do have an imaginary solution. So here's what here's where the I comes into play. So you can take that, you can split it up as the square root of 1 times the square root of 16. Again, we know the square root of 16 is 4. But if you take a look here now, here's the key to unlocking the square root of a number. If you take the square root of -1 or a negative number, you introduce an I. So if I take the square root of -1, I would introduce an I. Now, the proper way to write that would be 4, and then the I comes last. Just like in these examples here off to the right, it's always the real part first, and then the I coming second. So the square root of 3, again, you can split that up. Square root of -1 times the square root of 3. The square root of -1, we used to not be able to do that, but now we can. Again, comes right back up to here. It is I. The square root of 3 we don't know, so we'll just leave it as the square root of 3. Square root of -20. So we can split that up again if you want. That's just -1 time, -1. Oops. Let me fix that quick. The square root of -1 times the square root of 4 times the square root of 5. -1 is I. Square root of 4 is 2. Square root of 5 is just 5. So this would be 2i times the square root of 5. So that's all it does, is it helps you take the square root of a negative number. That's how you introduce imaginary numbers. So example number 1 here, identify the real and the imaginary parts. So I'll just go like this, real, imaginary. I'll just set this up real quick for all of them. All right, so the first one, the real part is 2. It's just this. The imaginary part would be 4i. Anything with an I is imaginary. Jumping over to the right, 1/2 is the real part, and there is no imaginary part. Jumping down to the bottom left here, -5 is the real part, and 2i is the imaginary. And then the last one, there is no real part, and the imaginary would be 6i. So solving equations really quickly, 1 or 2 steps. You see a problem like this, hopefully you know to introduce the square root. And normally you'd say that it's no real solution. But now we can take the square root of a negative number. We know the square root of 64 is 8, at least I hope, plus or minus 8, since we're solving. And then the square root of this -1 is now I. So there you go. No longer can we just say no real solution, but we have a way to actually solve. Jumping over here, subtract 26 from both sides. 2x squared equals -36. Divide by 2. X squared equals -18. Now we can introduce the square root again. Before we would have said no real solution, but we can actually do this. So it's going to be something I because of the negative. 18 we can break down into 9 times 2, and this is 3 and 3, so we would take a 3 out, put a 2 back. Just kind of a quick review on breaking down radicals. Okay, so here you can use imaginary numbers to solve problems we used to not be able to. So write the expression as a complex number in standard form. So when you add or subtract imaginary numbers, you can only add or subtract the real parts together and add or subtract the imaginary parts together. For example, letter A here, we can only add -1 and 3. Then we can add the imaginary parts, 2i plus 3i. So we're going to end up with 2 plus 5i. That's it. 2 minus 3 is -1. And then -3i. So you got to be careful with these negatives. So you have -3i minus -7i. When you have two negatives back to back like that, again, it's addition. So it's actually going to be a positive 4i, which is the rest of our answer here. And we'll go ahead and just do the last one quick. We have 2i minus I plus -3i. So 2i minus I will just be I, plus -3i would be a -2i. And then if you just take care of the real parts, so we have a -3 here, plus 2, we're going to end up with -1. So you can only add or subtract the real and imaginary parts. Just treat it separately. We can also distribute, aka multiply. Now here you have to be careful. So -I times 3 is -3i. Pretty straightforward, but here -I times I is -I squared. If I scroll back up, here's the other part. I squared is -1. So let me just jump over to the side here. So we have -3i minus I squared is -1. Change that to addition. We have -3i plus 1. And if you're going to write it in the proper form, the real part needs to come first. So it's actually going to be 1 minus 3i. Okay, I'll do one more of these here. I'll jump down to the bottom example. So distribute. So we get -18i. Distribute here. We'll have a minus 15i squared. Again, right here, no issue. This is the part you have to change. So -18i minus 15 times I squared is -1. -18i plus 15. And then just put the real part first. 15 minus 18i. Boom. Okay, we'll do some more operations so you can see the multiplication is getting a little more difficult. And now division. So jumping up here to the multiplication, this is it's just like multiplying binomials all the way back from Algebra 1. We're going to use something called the FOIL method, if that's how you want to think about it. It's just a fancy name for distributing. And here's how it's going to work. We're actually going to go ahead and get rid of the middle section there. So I'm just going to do something like that. Nice. Okay, we'll do the first and the last one. So here's how it works. FOIL, or distributing. So you're going to take the first number, 3, multiplied by the first number. So 3 times 5 is 15. Then you're going to take the first number again, multiply it by the outside number. 3 times 2i is 6i. Then we're going to take the second number. I should scoot this down a little bit. There we go. 4. Then we take second number times the first number, so plus 20i. And what do we have here? 4i times 2i is plus 8i squared. All right, so now we just have to combine like terms, and again, we're going to have to take care of this I squared business, but first, I'm going to combine these two in the middle. So 15 plus 26i plus 8 times, and at the same time, I'm going to change I squared to -1. So 15 plus 26i minus 8, and again, you're going to end up with like terms you can combine here. 15 minus 8 is 7 plus 26i. So there you go. That's how you'd multiply, a little more complex. We did some basic multiplying, basic distributing up here. Here we're taking two complex numbers, completely complex numbers, and multiplying them. Okay, I said I'd do one more, so here we go. Multiply the first two numbers together. We end up with 1. Jump to the outside. First outside, you get -2i. Then the inside plus 2i, and then last minus 4i squared. So start by combining like terms right here, and they end up canceling, so that's kind of nice. So I'm going to jump over here quick. We have 1 minus 4, and again, I'm going to take care of this I squared business right away. 1 minus 4 times -1 is 1 plus 4, or 5. All right, here we go. Dividing complex numbers. So the first thing you need to do is figure out what the conjugate is, the complex conjugate. So what you're going to do is look at the denominator here. And the conjugate is going to be that exact same thing, but just switch the middle sign. So instead of 1 plus I, it's going to be 1 minus I. And then what you're going to do with that is multiply the numerator and denominator by 1 minus I. And it's going to be like two problems like we did up here in 1, where we have to distribute in the top, distribute in the bottom. Okay, so starting up top, 2 times 1 is 2. 2 times -I is -I minus 7i plus 7i squared. So that's the top. On the bottom, let's pick a different color. Sure. 1 times 1 is 1 minus I plus I minus I squared. So up top, combining like terms, we have -I minus 7i. So we have 2 minus 8i plus 7, and again, I'm going to take care of the I squared right away. 7 times -1. On the bottom, we have like terms here. We have -I plus I. And this should always happen if you multiply by the conjugate correctly. You're going to get those middle I terms to cancel out. So we'll end up with 1 minus, and then I'm going to take care of this I squared again by changing it to a -1. And if we just hop up here quick to clean this up, 2 minus 8i minus 7 over 1 plus 1, if we just do the multiplying, and then last but not least, -5 minus 8i, if I combine these like terms here, divided by, where did it go? Divided by 2. So, a lot of work to simplify one problem, but the first thing you have to be able to do is identify the conjugate, multiply the numerator and denominator by it, and then it's just multiplying all over again. One last example here. So first of all, identify the conjugate. So we're going to multiply the top and the bottom. So take a look at the denominator, and all you do is switch the middle sign. So it's going to be what, -2 minus I. Okay, distribute. So -6 minus 3i minus, come on, minus 2i minus I squared divided by 4 plus 2i minus 2i minus I squared. So just distributing first outside, inside last, cleaning it up. Here we go. We have like terms here and here on top and here on the bottom. So negative 6 minus 5i minus, change these I squareds right away to negative 1s. 4, and again, if you do this correctly, you're going to get these middle terms to cancel out. So, boom, gone, minus I squared is negative 1. Hop up top, negative 6 minus 5i plus 1. If you could do the multiplication there, the simplification, 4 plus 1 in the denominator. Negative 6 plus 1 is negative 5. These are like terms, as are these. Minus 5i divided by 5. Now, every once in a while, this happens where all three of these numbers are divisible by the same number. And if you can, you should simplify that. So if you divide them all by 5, we end up with negative 1 minus I over 1, but the over 1 is not necessary. So if I simplify completely, there we go. Now there are a couple, nope, just one example for you to do here for yourself. So please make sure you have that done. And here's just another reminder about how the imaginary numbers fit into what we've already done.